I'm Anil Kumar. Welcome to my series on weighted mean and mixture related problems. In this video, we are going to derive a very important formula and a concept to solve such questions. We'll also see how weighted mean and mixtures are kind of related, right? So let us begin with the simple example here. We'll consider apples of grade A and grade B. So in case 1, we are saying cost of 10 kg apples of grade A is 40 cents per kg and cost of 30 kg of grade B apples is 60 cents per kg. Find the average rate of the apples, right? That means if you mix them all together, it becomes kind of a mixture, right? So we just mix them up. And what you really see here is that this is an example of a weighted mean, right? So this is basically weighted mean. The average cost is not 50 cents. You just can't add these two numbers and divide. Since the quantities which we purchased are different, right? So we purchased 10 kg of apples of grade A at 40 cents. That means this amounts to 10 kg times 40 cents, right? Plus the other one is 30 kgs for 60 cents. So 30 kg for 60 cents. Total, you got 10 plus 30. So that is how you find weighted mean, right? Now you can always calculate this answer, and then that gives you 10 times 0.4 means 4 plus 30. So that removes 1 0. You get 6 times 3 as 18 divided by 40. That is to say 22 over 40. Now, so when you divide 22 by 40, you can think about putting a decimal here because of this, and 4 goes 5 times, so it is 0.5, 20, and then again 20, so 0.55. So with that, you get the average cost, right? So let me write down here the average cost. Becomes $0.55 per kg. Clear? Now, say it is not 50, right? So there is huge difference between weighted mean and the normal average, and that is how you can see it. Now let's talk about case 2. Now in case 2, we are talking about same grade A and grade B apples are purchased in the ratio of 1:3. So now we are not giving you the quantities. So this time we are working with ratio. Here we were given quantities. Now the question is, if I give you the ratio, can you find the average cost? Now this concept is important because sometimes these numbers could be very big numbers. Ratios are simplified forms. Now what you notice here is the ratio of 1:3, which is same as the ratio of 10 and 30. So if we get the same cost, that means these quantities, when written in the form of ratios, give you the same result. Perfect. Let's figure it out. Now let's understand the ratio first. So when I say the ratio is 1:3, that really means what could be the quantity? If it is x the whole thing, then the ratio will give us x and the other one will be 3x, right? So in general, we could always write ratio as a quantity with a variable, x, right? Now, let's figure out the average cost. So now if I do the calculations for average cost, I'll work with x and 3x. So instead of multiplying by 10 and 30, I'm going to multiply this time by x, 40 cents, plus 3x times 60 cents, and I'm going to divide by x plus 3x. What do I get? Well, x is common factor here. I can take the x common. I have 40 cents here plus 3 times 60 cents, which is $1.80, right? 3, 6, 18. So which is $1.80. And in the denominator, I get 4x. Now I can cancel x and x. So what really happens is that you find that this x, the variable, is gone. We get the same result. Perfect. So if you add 0.4 to 1.8, you get what? You get 2.2 divided by 4, same as 22 over 40, which is 0.55. So again, we get the same average cost. So now again the average cost is what? Average cost this time also is 55 cents per kg. A very important thing which we learn in this part of the video is that these quantities can be replaced by simpler numbers to work with, and this strategy will be utilized in solving multiple choice questions in tests where you have to answer within a minute. Do you understand? So let's go on and see some more applications of the same thing and understand the concept further. Now let us consider case 3. We have actually generalized our question. The question again here is, grade A and grade B apples are purchased in the ratio of N1 and N2 at the rate of R1 and R2 respectively. Find the average rate R of the apples. So we have just got rid of all the numbers now and we are working with general variables, right? Which could be given any value. So we can derive a formula from here. You get the idea, right? So we need to relate the average rate with the quantity and rate for individuals. At present, we are taking 2 grades of apples, but we could extend it to many more, correct? That's the whole concept, which you understand from weighted mean also, right? Nothing new. Okay, so we say find the average rate. So average rate R, now I could write as product of this N1, right? So the number of apples of A type times R1 plus N2 times R2, right? The apples of the other type and their rate. Total quantity being N1 plus N2. So we get our general formula. And so we could always find the answer, which we did in the last case also. But see now, what am I going to do? I'm going to rearrange this formula and then work out in a different way. I could cross multiply, right? So I could write this as R times N1 plus N2 equals to N1 R1 plus N2 R2, correct? Now let's bring like terms together, N1 R1, let us say on the left side. So we have R times N1, so we have R times N1, and we bring this N1 R1 to the left. And we have here N2 R2, and we take this Rn2 to the left, to the right, Rn2. Now on the left side, I could take N1 common, okay, so I get R minus R1. On the right side, I could take N2 common and I get R2 minus R. Now dividing N by N1 by N2 is ratio, right? You get the other ratio on the other side, which is R2 minus R over R minus R1. So what do you notice here? We actually rearranged the whole formula and wrote the ratios of numbers with ratios of rates. Do you see that? So we have kind of related quantities with rate. Do you see that? So both are ratios, right? So both ratios, we have quantity on one side and the rate on the other side. Now that really helps in solving many questions. So that is something to admire. So N1 over N2 is R2 minus R1, where R is the average rate, right? So difference in the rate of this with the average, N1 is the difference in the rate with the average for N1 goes in the denominator. Do you see the kind of inversely proportional? So that is what we get. Now, this formula itself is a huge concept which we are going to explore further. But I hope you understand all these steps. So take a minute to see how we have done all this. Now, the question here, case 4 is, grade A and grade B apples are purchased in the ratio of 1:3 at an average rate of 55 cents per kg, right? So we actually found 55 cents per kg as the average rate earlier. So I've just reversed this particular question and I'm saying find the rate of grade A apples if the cost of grade B is 60 cents per kg. Well, you should get 40 as your answer since it is just the reverse of what we did, right? So what I would like you to do here is to pause the video, plug in these values, n1 being 1 and 2 being 3. So 1 and 3, and we know R2 60, right? 60 minus 55 in cents, and we know this is 55 minus, you don't know, you can find R1, correct? So this formula can help you to get the answer straight away. So let's try to figure it out. So if I substitute these values, let's do it in this side. 1 over 3 equals 2. R2 is now known to us as 60 cents of B, right? A and B. This is A on the top, B below. So it is 60 minus 55 over 55 minus rate of the first one, correct? So that is what we get. Now in the numerator, we know this is 0.05, and in the denominator, it is 0.55 minus R1. Let's cross multiply. So when you cross multiply, let me write down here now. So we get 0.55 minus R1 equals to 3 times 0.05, correct? So from here, we can get the value of R1. So R1 is equal to 55 cents take away 15 cents. And that gives you 40 cents. So this really confirms that our formula really works. Does it help you to understand the scenario? Correct? So the formula really works. And so we can actually solve mixture problems with this kind of a formula. Now let me give you another way to graph this. So what I'm going to show here is graph of this formula. So I'll use this place to graph this particular representation. How can we actually represent this? So what we normally do here is, let's say we have quantities n1 and n2, right? So we have these two numbers. We could start with rates also, right? So, well, this was a ratio. So let me put it at the bottom. Let's start with rates, right? So that will be better since we want to find rate here, right? This question was related to finding rate. So let me start with rates. We could start with quantities also. But since it was based on rates, we'll say let the rates be R1 and R2. And the average rate is R for us, right? This is the average rate. So what is R2 minus R1? So what we do really is average is middle of these two, somewhere in between. I shouldn't say middle. So when you do this, you can actually write this as imagining R2 is bigger. In that case, this will be R2 minus R on this side. And on the other side, I could take a difference of these two. Since that is a lower number, we'll write this as R minus R1, correct? So we get these two numbers. Now, if you want to correlate, then R1 and this is N1, correct? So this becomes your quantity in ratios, N1, and that becomes your quantity in ratio, N2. So basically, this kind of a graph will replace this formula, right? So in many cases, we call it alligation. So it's given a name alligation graph to work with, right? So I hope you're getting a concept. We have two rates here, R1 and R2. And what we get is the ratio of R1 and ratio of R2 on the other side, where R is the average or the mean value of these two, right? So the five things related here should be in the same units, rates, right? So, and then when you find the difference, you can get ratio, and that ratio could help you translate rates into quantities or any other units. So we will be solving many questions relating to percent, quantity, mixtures, and so many things using this concept. Let me take a small example to end this session, right? Where we'll use this particular format, alternate for the formula. So we are calling it a graph for now, and then see how useful it is, right? You've already seen the use and its application, but let's take one more example to end the video. Now here is an example which you'll find interesting, and you might have seen such examples in test papers. Let's look into it. In what ratio must coffee beans at $18 per kg be mixed with beans at $12 per kg so that the mixture is worth $16 per kg? Right? That's first part, right? And the second part to this is find the quantity of expensive coffee beans in 150 kg of this mixture. 4 choices are given to you. I would like you to pause the video and solve this particular question. Now, I am going to use the concept we just derived at. We are given rates, 2 different rates, and the average rate also, right? So we will say rate 1, which is expensive, right? Which is more expensive, which is $18. Let's say $18. Rate 2 is which is cheaper. So in our case, that is $12. And R is average rate, which is $16 per kg, right? So we know all this. What do we need to find? We need to find the ratio, right? So that is exactly what we did, right? So how do we find ratio? So let's write down. So we have our graph here. This is 18 going to be mixed with 12, getting 16 as the average. Perfect. So what you do here is you find the difference between these two. And when you find the difference, what you get? 18 is a bigger number. So 18 minus 16 will give you 2. On the other hand, difference between these two. So we'll do 16 minus 12. See, quantities are always positive, right? So even if you do the other way, you have to write a positive number, right? So remember that. So 16 minus 12 is 4. Now this gives you the ratio. You understand? So that gives you the ratio of R1, which is N1, right? N1 is to N2. So what is the ratio of N1 is to N2? 4 is to 2, or 2 is to 1. Do you see that? So we got the ratio that the amount or the quantity of expensive is twice than the cheaper one in this particular case, where the average is 16. It makes sense. 16 is shifted towards 18, right? So weighted mean, the weight is more towards 18, and that makes sense. Perfect. So we get our ratio, and the ratio is 2 is to 1, right? Now let's look into the second part. But you must have realized one thing: without any heavy calculations for weighted mean, we got our answer. We're just working with such small numbers. And within few seconds, you can answer such questions in any multiple choice test papers, including SAT, even AP Maths, correct? I hope that makes sense. Now, let's get to question second part, which is find the quantity of expensive coffee beans in 150 kg, right? So now we have 150 kg in all. The ratio is what? The ratio is 2 is to 1, right? 2 is to 1. So total amount is 3, right? So that is the total. How much is the expensive one? It is 2/3, right? So 2/3 of 150 is the quantity of expensive one, right? So let's figure it out. 2/3 of 150. So if you simplify this, 5, 0, and when you multiply, what do you get? Twice 50 is 100. So we have 100 kg of expensive one. Do you see that? So we get our answer. So we really have 100 kg of one, and the other one is 50 kg. Do you see that? They are in the ratio of 2:1. Cheaper one is 50 kg in this mixture of 150 kgs, and the expensive one is 100 kgs in it. And that makes the average price of $16. Does it make sense to you? So I hope you are getting into it, that how beautiful this method is. So now we will be solving many questions based on mixtures and weighted means with the help of this particular method. I hope it makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Share my videos with your friends. Thanks a lot and all the best.